In this video, we're going to focus on how we can put in multiple threshold lines here. As you can see here, we have this red one here, and we even match it with the colors. And then the yellow most likely is here as well. The green one is here, the purple is here, the orange is here, and the black one is here. So let's start to look how we can do this. So let's start to look how to add multiple threshold lines for each segment in a polar area chart. First of all, we need to get, of course, our default code, which you can find on chartjs3.com getting started. Once you're on here, just copy this entire code here. Oh, and I didn't want to do that. Alright, sorry. I just need to get used to this new mouse. There we are. Just copy all of this. And if you want to understand all of that code, please watch this video here. So paste that in there. And then what I'm going to do here is cut that out and put that in there. Save, refresh. So once I have this, what I'm going to do is I want to convert it into a polar area chart. So I'm going to say a polar area, save, and then of course remove the scales here. The reason why is we don't have any X and Y scales here, but we have a radial scale. So we just do it like this. There we are. And next what I want to do here is to remove the tooltip to avoid any confusion. So I'm going to say here, plugins, tooltip, and I'm going to say enable false, save, refresh. And then there we are. Alright, so the next thing what I want to do here is start to create the plugin. So after the options, comma, I will say plugins, bracket, and then what I'm going to do here is I'm going to call this a multi-threshold line. So we have multiple thresholds for every single segment. And then, once we have this, plugins, then I'm going to say here, the multi-plugin block, and then we're going to say constant, this, plugin, and then we're going to say ID equals that. And then we're going to say here, when would we like to draw the lines? In this case, we're going to draw the lines here on top after the data set has been drawn. So we're going to say after data sets draw, and then we're going to have here the arguments, which is chart object. We have the arcs, and we have here the plugin options. So once I do this, the next thing what I want to do here is to do an object destructuring. If you don't know what's an object destructuring, I would recommend you to watch my, go in the description box. There's a video, understanding object destructuring for Chartjs. So I'm going to equal chart, and then what I'm going to use here, most likely we only need to use a few. First of all is the CTX, and we might need the data that might be useful, and then here I'm going to use the scales, but specifically the radial scale, because there's only a radial scale, there's not an X and Y scale here. Once I did this, I'm going to say here ctx.save to save all items above. And then what I want to do now is start to think about what do we need to do here, because we have some work to do and we have to understand the logic of that. So the first thing what I want to do is I want to know how many items do we have. Well, in this case I'll just say here constant, and let's say here I guess here the segments, total segment. In this case I'll make it hard-coded 7. Later on we're going to soft code that. So that's the first one. So we have 7 segments. That would mean that every line will stop somewhere and then the other one will continue. The next thing that we need to play around with is, of course, normally you're used to an arc, and if you watch my videos I always use arcs, converting it to a 360-degree model. However, that's not possible, or it might be possible, just more complicated. So I'm going to use here really the pi structure, which is the default structure. So that can be tricky, but if you follow along it should be absolutely fine. So what I'm going to do now is let's start to do with the very basics. I want to calculate the height from this point to there, and the reason I want to calculate this is just basically because I need to know every value here in this scale. How many pixels is it from here to there? And the reason this is necessary is basically when we draw the arc. Well, maybe it would be even good to just draw an arc. So I'm going to say here CTX. Let's start to draw something. We say begin path, which indicates we're going to start from scratch. Now other elements are connected. Then I'm going to say here CTX.line width, and this would indicate we're going to have here a line thickness of 3 pixels, and then I'm going to give it a color, ctx.stroke style. The stroke style, I'll make it simple. We make it black for now. Once we have that, I'm going to say ctx.arc, and the arc consists of multiple values. First of all is the x starting point, the y starting point, and then we have here the radius, and then we have here the angle S for start, and angle end for ending, and then we say here false. And this is for counterclockwise. By default, it's most of the time false unless you want to go back instead of going clockwise the other way around. So we have this, and then if I would do now here, just very simple, a ctx.stroke to draw the item, and then we say ctx.restore to undo anything, to undo all the settings above. Now we have it, but of course we didn't assign anything here. So if I would just say here, let's say 400 by 250, or maybe the 250, and then the radius would be a radius of 20, and then the starting angle will be, let's say Math.PI, and then multiplied by 0, because a full circle is 2 pi, and then I'm going to say here Math.PI multiplied by 2. If I save that, refresh, there we are. So we have a circle here, absolutely phenomenal, but of course it is off. So what we want to do is put in the center. We have these segments, but we need to also, well, let's try to put this circle in the center first, and then calculate how much is this pixel amount here. Let's do the circle first. So how do we get this one here? That's the x and y. So in this case, what we need to do is here is in console log. I'm going to dig deeper into the r, or the radial scale. So I'm going to say here console.log. I'm going to say r, save, refresh, open up the developer tab, and you can see here all of this information here because it loops multiple times. Anyway, we have the ID of r, which is the scale object. And then we can look here, we can find all this beautiful information, but what I need to know is basically the center. And there we are. You can see here the y center and the x center. And what is very important, the x center is basically width from this point to there divided by 2, and the y center would be this point to this point, or not even this point, but from here, this top here, this needs to be considered as well. You can see top is 32 pixels, so basically minus 32, and then we'll calculate the top, and that's 36 pixels here, or 366. So what I'm going to do here is very simple, r.y center, and the other one will be r.x center. If I save this, refresh, there we are. So that's the first part. The next part will be figuring out how many pixels is this here. So to do that, what I need to do is I need to calculate basically, first of all, the width from this point there, and afterwards I need to divide this by the total amount of values on the scale. So what we can do here is basically this. I'm going to just calculate, I'll make here a constant. We say here constant, and we can say here the true height. And the true height would be what exactly? Well, I'm going to say here the r.y center, which is the starting point here, minus the top. Minus top. And the top must be, of course, r.top. That's very important. So the moment we have this, if I do now console log, we should get here the exact value of the true height. Let's put that one, and I'm going to comment out that one and say refresh. There you are, 344. Or sorry, 33.4. 334. So that is the number. So that's the first one. Next one, what I need to do now is figuring out this amount divided by 18, or I don't want an 18, I want a soft-coded number. So what I'm going to do next is I'm going to say here again, console R, refresh, click on one of these, and then what I want to do here, I want to figure out the end value. The end value indicates from this to there, what is the ending value of the scale. So what I'm going to say here is, not the segment, but the true height. If I say divide by r.end, or what is then eventually the value here, this should be maybe a proper name. So we can say here constant, and what is maybe a good name to give here? Well, this would be if. This would be a specific value, let's say number 2, and then we'll calculate from here to there, then this would be basically the radius. So I guess we can just say here, radius equals the true height divided by this, and then there we are. And then what I need to do here, multiply it by 2. For example, if I save this, and let's copy the radius here, put that in there, save, refresh, there you are. So this looks nicely. So if I do 4 here, let's see if it works correctly. Most likely we need to adjust something. As you can see here, we're slightly off with 1 pixel or 2 pixels. So what I need to do now is, because of this radius, it calculates an additional pixel here. I need to reduce that. So how do we going to do reduce that? Is, well, we have this number 4, and then we're going to say here, well, we're going to give this priority. Then we're going to deduct this from whatever the value is, and the value will be number 4 in this case, and then divide by 2. And the reason why I'm doing that is because we have the 2 pixels, because here in this case we have that. So if I save that, now we are showing it nicely. Alright, so now we have this, and this now can be soft coded. So we're going to soft code that later on. So the next thing what I want to here, now we have this part, and I have the Math.PI. So if I do Math.PI, and if I just say here, for example, 1, save, you can see here, it starts here, and this is the starting point of it, and this is the reason why I'm not going to use the 360 degrees, because the 0 and the 360 is basically this point here. This is 270, and then if it's from 270 goes to 360, you need to recalculate back to 0, and that can be quite tricky. What I need to know is basically for every segment, how many angles from this point to that point there, and calculate that. So to do that, I need to first get the starting point here. So if we know that a full circle is 2 pi, and here's 0, then the going back would means minus 1 pi. So we can test that. We can say here, multiply by 1 minus, and I'm just going to say this one here, let's say here 1.5. I have no idea what will happen, but let's see. Oh, okay, that is far too much. So let's say here 0. There we are. Now we are up here, but of course on this point, so I need to say here not minus 1. Let's say 0.5. There we are. So now we have this starting point. That's the starting point, and later on we have to go and use a for loop here to make sure that this works accordingly. So what we're going to do now is, and this is the tricky part here, we need to calculate this. So what I'm going to do here, another constant, and this constant will help us to calculate how many items we have. And I'm going to just borrow the items based on the data here or on the labels, but of course you could do it any way you want. If later on we can make a separate plugin value that we can use from it. Oh, we have the segments here already of 7, so I guess we can just use that for now, and later on we can borrow that. So we have the segment number 7, and what we need to do here is, let's see, and now it becomes slightly tricky even for me. We probably have to make a for loop with all of this, and I guess we can make a for loop here. And what I'm going to do is, maybe we can just go to grab this item here and create this value, so that we can calculate how many segments we have plus how many data points or how many lines we have for the values here. So what I'm going to do here is, we're going to go down here. I'm going to show you a very useful trick. In here, comma, I'm going to say here, let's grab the item, which is the ID of the object, copy this, put it in there, column, and then here we can say here the value. I'm going to just call this a threshold value, or maybe you can say here line value or something like that, anything you want. Then I'm going to make this a bracket because it's an array, and I'm going to just say it will be number 2. So basically on the scales, number 2, and then 4, 5, etc., until we have 7 segments or 7 items. 2, 4, 6, 8, 10, 12, and finally let's do number 9. Alright, now we have this. Now we want to grab this item here. So we have these segments here, and just calculate how many segments we have. To do this, what we can do is just basically this. We can just say here, plugin options. There's a dot, and then we're going to refer to this line value. And we will understand it immediately, and there is a dot length. So now we understand immediately this item here. So that's the first one. And this, I guess we need to move this up. And the reason why I'm going to move this up, we're going to create a for loop now. Because now we have the ingredients for the for loop. Because we have the length here, or the segment value. So we say for, we can say segments dot for, and I guess maybe this is a wrong term for that segment. Well, maybe it's alright. What I want to do here is I'm just going to grab this one because I feel like that is probably a more better item, because I want to grab these values, not the length of it, but the exact value. Let's say here for each item, and then we're going to say here the value, and this value here we're going to do the following. I'm going to cut this, paste it in there, proper indentation. And now what I want to do is I want to make this a bit more dynamic. So I'm going to say here the value, and the value is this, put in here. And the reason why is the value is this item here in the for loop. So once we have this, we have all of that. This is dynamic. Alright. Let's save that and then refresh. There we are. So now we have 7 items. 1, 2, 3, 4, 5, 6, 7. And the color, you can see number 9, everything is exactly matching. So what I'm going to do now is the following. I need this to be, or at least the position of this, which is the angle start. Let's give it proper name, constant angle start equal. And our position is basically this. And once we have that position, what I want to do here is to look, let's see what we're going to do now, and this is a slight tricky one for me as well. So what we're going to do now is basically create a formula out of it. So we have this Math.PI, this is the starting point, and then what I want to do is I want to plus, oh, didn't want to do that, sorry. We have this, and then we say plus, and what we're going to plus is basically how far we need to go here as a starting point. And to do that, I'm going to say here Math.PI, and I guess we need eventually the index value as well. So we're going to say here, I'm going to give this priority, say Math.PI multiplied by 2, because remember, a full circle is 2 pi. Then we're going to divide this, and we're going to divide this by the threshold value item here, that is the threshold value, where is that, the line value basically, which is our value, if I'm not mistaken. Oh no, I'm afraid that this would be the segment. That's let me double check. Yes, that's the segment. So divide, not here, sorry, here, divide by the segment, which is 7, and then once we do that, multiply by whatever the index would be. So we need to say the index. And then, of course, our index, if it's 0, it starts here, but I want to go here. So that will be the next starting point then here. So we have this multiplied by index, or we can do it like this. Alright, so if this works, and we do it like this as well, we put here parentheses and see if this all works. For me, I'm also slightly, this is like a mind twister for me. Refresh. Alright, interesting. Did I save this correctly? Yes, I did. So we have multiplied by index. Alright, we have the segment times 7 multiplied by index. Hold on. Alright, so as you see, I'm absolutely not focused on this one, because the reason why it doesn't work, of course, is we didn't put the data in there. That's really bad. Make sure we put in the variable in here. Save. Refresh. Alright, so as you can see here now, it started to do something. And of course, it does a lot of weird stuff. So what I want to do here is, we're going to do this one now, and then we can double check that. So I'm going to copy this, say here, end, and the ending value is basically here as well, the same. I have here the index, but the index starts at 0. So now what I need to do here is plus 1. So we need to always increase by plus 1. So we save that, refresh. Alright, not yet. So we have this index here plus 1. And of course, copy and paste that in here. Same mistake. Save. There we are. Alright, so now I guess it really works nicely. But what I want to do is, because you can see here 2, 3, 4, or 2, 4, 6, 8, and then this would be 9, and this is 10. This works, but what I want to do is make sure we have the color as well. So I'm going to put in a color. So I'm going to calculate this. And then one thing I might notice, and if you notice as well here, this one might be slightly thicker. And the reason why this is thicker is because it moves a 0.5 pixel. So I'm going to solve that. So how can I show you that one? Let me convert this. I'll go make this one 9. Save. Refresh. So you can see here now this one, and then let's make this one 12. You might see very carefully slightly, and the reason why is because there's 1, 2, 3. So what I need to do here is, if I'm going to, I need to push that a bit down, and that's basically a floor calculation here. Where are we? Divide by 2. That's this one here. But then, what I want to say here, math.floor, because if this will be 4. If it's 9, it's 4.5, and that creates the issue. So if I save that now, we do that, and now it's exactly pixel perfect. Alright, that's done. Let's get the colors here. So now I have some colors, and then we're really done with this one here. The colors could be done here, or we could get it from here above. I'm going to get it from above because we have here the data. So I'm going to grab this data here. And what I'm going to do here is I'm going to say here, nothing there, but let's look at it in here. We're going to say data sets index 0. If you're wondering why, let me show you. It's from data sets, and then here border color index, whatever the index would be. So here dot border color, and then this depending on the index that we grab from here. If I save this and then refresh, there we are, and this is basically the colors. You can see here they are matching perfectly, and you can of course adjust this. Let's make this 18. What happened then? Refresh, then it goes here. Absolutely phenomenal, and this is basically the way you can do it. So if you enjoyed this video and maybe only need a single segment, in that case I have another video that I can recommend, just how to add the threshold line in the polar area chart in Chartjs, but then a single threshold line instead of a multi threshold line.